All right, so I think we're going to kick it off here. It pretty much has stabilized. We'll see if people come in. I'll add them, but I'll do my best to mute them as they come in. I want to thank Jared and Eric for setting aside some time to talk about um, elastic strength development, or plyo or plio, depending on who you talk about or who you talk to, metrics. So they both work for the Memphis Grizzlies. Jared is the performance therapist. Eric is the head strength and conditioning coach. I've known Eric for quite a while and known Jared for a while as well. He's also on the board for the performance enhancement SIG. So without further ado, I'll turn it over to both of you and let's hear what you got.
Appreciate it, Scott. So, like Scott said, we're excited to present today on reverse engineering elastic strength development, a transdisciplinary approach. Which really, when we look at that word transdisciplinary, I think that's a big component of what we want to relay and get across today, of making sure that we do have this ability to, whether you're in a team sport environment or you're in a private practice physical therapy clinic, there's going to be this time where you have to communicate and kind of orchestrate this symbiotic relationship. So we want to do a good job of trying to showcase maybe how we can overcome some of the potential barriers that we might face, especially revolving around a concept of elastic strength that can be kind of challenging and maybe has some ambiguity. It's often seen a little nebulous. So we'll get into some of the specifics as we go through this presentation. But as Scott alluded to, I'm going on my third year as a performance therapist with the Grizzlies. Before this, I was with Rehab to Perform. So it was a sports physical therapy clinic out in Maryland. And I am now currently a lecturer with RTP Academy, where really what we're trying to do from a continuing education standpoint is to help out with disseminating information that pertains to bridging this gap, if you will, of return to sport, physical preparation, as well as the reconditioning process. So a lot of critical thinking and a lot of exercise prescription, regression, progression, things of that nature.
Awesome. Yeah. Thank you all for being here today. I'm Eric Schmidt. I'm the head strength and conditioning coach here. I've been working with Jared for the last about 2.5 years. So I'm going on to my third year now with the Memphis Grizzlies. Spent most of my time in college prior to joining this particular group. So it's been, good 2.5 years now. And again, it is really a really tight knit group that we have working with this team. And there is so much collaboration that does occur that, is really unique to kind of my upbringing as a strength and conditioning coach. I've never been in an environment where kind of we work this closely together with athlete care. So definitely want to be able to talk about, those particular aspects of the role and how we kind of manage similar athletes with single care. So that'll be a big part of what we're going to be covering today as it pertains to the elastic strength. So hopefully get as much of that across as we can.
All right, well, let's get started. So you see we have some key objectives here that I'll have you all read, but really the big thing, and for anybody who's heard me present, I always kind of preface it with, we really don't want to specifically give concrete answers, right? Our goal is to be a catalyst for critical thinking, for more of this pragmatic decision making, so we can be maybe a little bit more agile and a little bit more pointed in regard to the why, the what, the how, and the when behind our implementation of different tactics. And it really does all start with asking better questions. So some of the questions that we're going to attempt to try to answer, or at least shed a little bit of light on, are the following, right? So we're going to describe the mechanisms that contribute to elastic strength development and the respective adaptations, discuss requisite constituents or variables that ensure athlete preparedness for elastic strength progressions after extensive time loss cases, but even with this, it's not going to only be things that pertain to time loss cases. We'll just look at an athlete that maybe doesn't have the appropriate constituents available throughout their athletic development process. We want to dissect the relevant kinetics and kinematics of respective jump landing maneuvers and how we could potentially manipulate different components of those to get the adaptations that we want. And then lastly, develop some heuristics or maybe these mental shortcuts or these mental repositories, if you will, of objective metrics and attempt to intervene on these rate limiters for performance enhancement and reconditioning cases. So these heuristics that pertain to the objective metrics, you'll see a lot of those when we get into the case study that we'll do a little bit later. And when we introduce the case study, we really do want you all to turn off your mics at that point and kind of have this communication back and forth. We want to hear everyone's thoughts when we get into some of the questions in regard to that case study. So I think it'll make for a nice dialogue. And again, just making sure we're prioritizing this concept of critical thinking to ensure that what we presented on is actually kind of hitting home, if you will. So integration versus isolation, right? So we already kind of said that this is a transdisciplinary approach that we have. And this is a concept that, to be quite frank, is somewhat lost. And I think it's because, there is and there will likely continue to be this tug of war in our industry where we align ourselves with a tribe that can incite, confirm, and really does kind of perpetuate our beliefs. And at times this manifests as this group polarization that we have between different tribes or professions. And unfortunately, this leads to these ideological silos, these echo chambers, and we kind of wall ourselves off from really appreciating the complexity. And we just function off of these dichotomizations and we lack some of the essential ingredients like humility and ambivalence that I think would help us to navigate some of these more challenging athletic cases. So all of these things kind of create this perfect recipe for divisiveness and this illusion of knowledge, because we remain a little bit more myopic than what we should, and we're willing to uphold our beliefs no matter what without having to consider counter evidence or other perspectives, which we believe are kind of these critical cornerstones for critical thinking. So, when we think about our respective tribes, if you will, or our professions, so whether you're an athletic trainer, a chiropractor, physical therapist, a strength coach, there's so many available systems and methods that we're exposed to, and it's easy to become emotionally, socially, financially, and psychologically attached. And again, this just continues to kind of fuel that cycle, that cycle over and over again. So what we think is that we should probably try to take a step back and have this aerial view as opposed to just being myopic and saying, hey, what are the commonalities amongst all the different systems? And maybe this can help us to find a solution to drown out some of the extraneous noise and ultimately perhaps understand what may matter more or what's potentially more relevant as opposed to only looking at the dissimilarities that exist within those different methods. If we really think about it, we all do share similar intentions, which is to ultimately get the patient, the athlete, or the client to successfully perform their required or desired goals. And it's really, our epistemology, right? So that's the why we believe X, Y, and Z. These things should probably be discussed a little bit more, and they're kind of the drivers that dictates our chosen methods. So, when we discuss a rather deep concept like elastic strength development, or as Scott alluded to, there's different names and verbiage that people will apply, plyometric, which Eric will kind of unmuddy some of that a little bit and get into the semantics later. But there's a vast difference of opinion between the tactics that we should use when it comes to which tribe you tend to be with, whether you're a strength coach or a physical therapist. So the more we start to understand the similarities between the methods and we're willing to actually communicate and have these conversations, I think we can converge on more efficacious and effective solutions, right? So the more we kind of play this tug of war game, it kind of just perpetuates us being more entrenched within our hives narratives, and it stifles our capacity. So, this is where that concept of really having integration as opposed to being siloed and isolated really makes for a nice framework to allow athletes to get to their required activities. So complex does not equal complicated, right? So we now understand that first, we have to unmuddy the waters of making sure we have appropriate communication. and having this integration. But then we also have to make sure that we understand the terms complexity versus things being complicated. So as movement practitioners, and when I use that word movement practitioners, again, I'm referring to anyone that deals with the human organism. So again, athletic trainers, physical therapists, strength coaches, as these kind of clinicians and practitioners, we're inherently encountering tremendous degrees of complexity on a day-to-day basis, being that the human organism itself is a complex, adaptable system. So now when I use this term complex in the case of humans, what I'm really doing is referring to a system that has characteristics of being dynamic, open systems with non-linearity, that self-organizes and ultimately can't be traced back to its original entity or its original input, meaning that this concept that we typically employ subconsciously at times of reductionism might not prove to be a viable strategy, as this would indicate that the outcomes and responses and manifestations that arise are due to the sum of the system's units, and they can be predicted, which we are seeing that they actually can't, because we're subscribing to this notion of complexity. So all of this essentially means that the behaviors of the organism arise from multi-level, multi-system interactions that really do result in new interactions and new pathways that we couldn't have foreseen or predicted. And all of this is to say that ultimately we should accept uncertainty, and its relationships are always non-linear. And so this is why I really do love this term chaos engineers, because I think that's really what we all collectively are. And so this definition of a chaos engineer is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. So I know that's a mouthful, that's a lot, but if we really analyze that definition, this really is medicine. So we apply stimulus A, so medicine, exercise, manual therapy, perhaps, with the expectation of increasing resiliency of the system to perform within the demands of their environment. And then we reassess, and we apply stimulus B, and so on and so forth. So that cycle continues, and we should probably have some audits or some checkpoints in place as well, just to discern whether or not the stimulus that we implemented actually resulted in the adaptation that we were trying to seek. So I think the sooner that we begin perceiving what we're managing as chaos and our interventions as these experiments, if you will, the sooner our process can reflect the reality of the situation. And all of this is even more true when we discuss something that is made as complex as elastic strength development, which is inherently complex. And a lot of times I think that it's made unnecessarily complicated. Where we are, adding more noise, or it's reduced to a level that is maybe too remedial in nature, and we get this kind of paralysis by analysis. We're hit and inundated with so much information. We don't know where to start. We don't have an appropriate framework. There's a lot of different concepts to understand. And so our goal with this presentation is to help provide these many conceptual frameworks, as you'll see, that provide a signal and hopefully unmuddy some of the water of elastic strength development, creating these simple solutions for this complex problem.
Yeah, so since we are all chaos engineers, that's kind of our working title here together. We're definitely going to have a lot of crossover between kind of the different things that we do within our environment. And so, given the complexity, given the chaos, it's really important to come together and have a united mission and a really united vision to carry out what we do, so that our team can, again, define maybe what's most important. So allowing that our team to have the opportunity to make that known and state that together really helps kind of form this alignment that supports our ability to work together. So for the purpose of this presentation, we're just going to say our mission here is to provide unrivaled care and unconditional support in all areas of health and performance. And our vision to really make that happen is to cultivate this interdisciplinary team this interdisciplinary agile framework to support the elimination or the attenuation of constraints which impede performance and which potentiate injury. And then from there, we can more clearly define like responsibilities utilizing this approach of domain expertise. And really, it's my preference to define the responsibilities based upon the domain of expertise versus thinking of like roles, due to that inherent crossover of care that's necessary for optimal functioning in a high performance environment. So yeah, it's important to maybe look at this and say, hey, what's the expertise that each one of us has, and potentially look at the specific things that maybe we bring to the table to really cultivate this environment. Because the last thing we want to do is we don't want to get into like these turf wars, right? Where if I walk in the room and I see, my boy JB over here doing deadlifts, and I'm offended because I'm a strength coach, and that's like deadlifts belong to strength coaches, like that would be a problem, right? So really we have to again come together and define that domain expertise. So anyway, sharing that mission, sharing that vision, and just being real about what we bring to the table is really important. And then beyond that, we also have to be real about the necessary dosage that the stimuli that we deliver, both as strength coaches and as rehab professionals. Like we have to be real about what kind of dosage it takes, both from a volume, a frequency, and intensity standpoint, to actually acquire an adaptation. And I think that helps to, again, delineate maybe some responsibilities amongst the team. Because if we have an athlete that, for instance, is one of our goals is to improve maybe a joint range of motion, and I only get 30 minutes twice a week with that individual, where there's other qualities to work on. Maybe my time is not suited towards trying to improve that particular aspect of the performance spectrum. Maybe that belongs to someone else who's going to have more time to deliver that, that volume, that frequency, that intensity for that particular adaptation. So really, really understanding that. But all that to say, hey, what is it that we bring to the table? From a domain expertise standpoint, the things that I would say would fall under kind of my domain would be the development of emergent mechanical and metabolic constituents of performance. And so, mechanical in reference to those kinetics, the kinematics, the big hitter things, and then the metabolic, really dealing with the capacity of being able to carry out those particular things for long periods of time. So that's what would fall under my domain.
And then, kind of just going off of that, when we look at specifically in this environment where I am currently, and this might not pertain to everyone, but I think it's a nice exercise eventually to do of what is your domain expertise within your current environment and the constraints that you might have. But my domain expertise, thinking again, rehab, reconditioning within this organization, is the development of basal level constituents that service emergent mechanical outputs. And we'll get into some specific examples of how that looks and how it pertains to this elastic strength development continuum. But really all that means is we're trying to make sure and ensure that the athletes possess the requisite joint options or availability to, for one, be able to achieve a particular position that we think is necessary for them to acquire a certain stimulus to that tissue. But then also we want to make sure that once they can access that joint range of motion, so thinking about giving them letters of the alphabet, well, now can they coordinate that newfound joint potential or range of motion into something that is meaningful and purposeful? So that would be, okay, I have the letters of the alphabet now available to me. I can access A through Z, but can I construct a sentence? Can I construct a paragraph? Can I construct a book? Those are going to be the more emergent types of movements that need to be coordinated to where I can navigate and kind of negotiate my body against gravity. And now I can potentially start to load that in a way that's more meaningful, where we're talking about things such as impulse, specifically related to elastic strength, which again, we'll get into some of the nuances and specifics of that in some upcoming slides. So, here, we're going to get into a little bit of what I would call constraints-led lenses. So, I'm sure people have seen various versions of the Venn diagram with organism, task, and environment that illustrates how movement is this emergent and dynamically influenced phenomenon. But these constraints can also be viewed as potential variables that are modifiable, and they influence load tolerance, and they can maybe even serve as moderators to injury. And ultimately, the constraints that are modifiable will become our heuristics or our buckets of need. So there's this interplay with all these different constraints, but there probably should be this first line of defense or this tiered system that's going to be predicated off of subjective information, but even more importantly, the objective information that you're going to acquire through your process that you have. And this is going to be influenced by the emergent level of the injury or pain. And again, making sure that we're not only looking through the lens of an athlete having pain or injury, but also just the development of these athletes as well within their given sport. So we could likely have this downstream effect of other variables by addressing the one we believe to be perhaps the most responsible and modifiable, especially if we keep in mind this principle of Occam's razor, which I know people have probably heard me talk about quite a bit. I do think it is a very important principle to have as a clinician. And all that simply means is, the simplest answer often suffices. And it's not to say that the simplest answer is always correct, but what Occam's razor really does is to say the least amount of assumptions that you ascribe to a hypothesis is typically going to be the most effective solution. For every assumption that I add to the hypothesis, it lowers the probability of that being the correct answer. So I think that helps us to determine kind of this hierarchy of where we should start and what needs to be resolved or rectified, what we view as perhaps being a rate limiter, in our case, the expression of elastic strength development. So, looking at these different constraints, and I won't belabor this slide too much, but we have the different lenses that we can look through and we can kind of sift through where we have personal structural, personal functional. So that just pertains to the organism itself. Then we have task related and environmental. So specifically, when we look at the personal, structural and functional, structural are going to be things like anthropometrics, body composition, muscle architecture, all the variables that take perhaps a little bit more time to manipulate, as opposed to the functional constraints, which are things that I would kind of think of as being like these biomotor, biodynamic, which we'll get into that terminology a little bit later as well. But think of those as being outputs, so muscle strength, power, the fatigue that might be incurred on a peripheral or even a central level. Then we kind of move over to this task-related constraint, which is the interaction between the person and environmental constraints. So for example, these are typically going to be contingent on the rules of the game, the boundaries, the borders, the things that I am not allowed to do that will inherently restrict the options that I have afforded. So for example, like defending an opponent or dribbling a ball to get by a defender on the court. In our case, specifically the task of being able to get from one end of the court to the other with the ball, well, you have to make sure you dribble the ball. You can't pick it up, stop, and then dribble again. So there's different task-related constraints. And then lastly, we look at the environmental, which are things like playing surfaces, shoes, equipment, climate. They're typically things that are external or extrinsic variables that don't inherently pertain to the athlete, but they influence, again, the options that might be afforded to answer the movement question. And now it's important to note that these can definitely be manipulated, these environmental constraints, but often not within the actual competition. So what we tend to do is more so focus on the task related and definitely the organism or person level constraints, again, delineating those into structural and functional, where perhaps, my domain expertise within this specific environment might revolve around trying to resolve some of those structural related impediments that are creating boundaries on the expression of movement, as opposed to functional level. Potentially some of those, depending on where this individual lies within this continuum, might kind of belong a little bit more to E. Schmidt. So, the last thing that I really want to elucidate here with these constraints is that they interact with each other on multiple levels in order to allow this individual to handle afflictions or perturbations to the system. And they do so because we can create these rapid accommodations. We can kind of have these compensations, if you will, to meet the objective. And this is actually connected to this term variability. And when we become injured, or when in pain, or the specific tissue might actually lose a little bit of variability and become perhaps a little bit more rigid as a protective consequence. And so what actually happens in certain cases is that other constraints may increase their variability or their expression in order to accommodate for the injured region. And it's important to note here, though, that this is based off of whether those constraints actually have the requisite resources to be of assistance. Now, this is all kind of theoretical in nature, but you can deduce from the different manifestations that you see often of stealing resources from other areas, and perhaps now we're putting them into vulnerable situations that might potentiate injury as we're exceeding that particular tissue's envelope of function, if you will. So, the big things to note is that these repeated micro injuries might eventually result in or accumulate towards these avalanche or macro injuries, because the constraints are further constrained. We're deploying them of their resources, and they're never restored to provide additional strategies and options. And so, again, just thinking about as we proceed with the rest of this presentation, each of these constraints can be looked at as performance inhibitors or even indicators for certain athletes in sports, and they can change, they can interact with each other differently over varying timescales. And so the goal is to determine the hierarchy of needs and develop these buckets that capture the relevant variables of what actually needs intervening. And you'll see as we get kind of within our case study specifically, this reverse engineering process that might pick up on certain constraints if we have embedded within our process objective information that allows us to determine what is the rate limiter for the expression of elastic strain development.
Yeah, so we just spent a good amount of time talking about a lot of different things that aren't necessarily elastic strength, but I think that last point, talking about if you utilize a constraints-based approach, then realistically, you might identify constraints within the process that take you away from quote unquote elastic strength that are very heavily involved in actually returning an athlete or training somebody to improve their ability to work on those particular qualities. But ultimately, we got to define this elastic strength anyways, because I think it's definitely a pretty nebulous term, especially when a lot of people just throw out like plyometrics. So Scott kind of alluded to, like, are we talking plyometrics? Is it plyometric? Is that just somebody mispronounce it? What are we talking about here? And I think it's actually I'm not a huge semantics person, but this is one where I do think we need to kind of get on the same page and really figure out what we're talking about, because there's just so many different ways that we use the term, plyometric, elastic strength, reactive strength, stretch, shorten cycle training. There's a lot of different things that people throw out there. And so we'll kind of touch on a few of those and then hit on why, we use the term elastic strength as kind of the, to define this particular type of work. So, I feel like looking at definitions on Merriam-Webster is probably the first place we'll start. And if we look at, just straight up, what is plyometrics? Because that's what I think the most common term is, Merriam-Webster would define plyometrics as exercises involving repeated stretching or rapid stretching and contracting of muscles to increase power. And so that last part, contracting muscles to increase power, if you understand kind of some of the components that go into this, you might recognize there's a little problem there. So muscles might not be the most involved tissue, in that process of enhancing power, because to discuss how the muscles contract to enhance power, that's a poor description of what makes this type of training, so effective. The tissue responsible is really not the muscle hardly at all. So, when discussing this form of training, we're really talking about very fast actions, and muscles are remarkably slow, so they're strong, but they're very slow. So in order to kind of move fast, we really do use an elastic process. It's elastic energy. So, muscles, if we think about just muscles generate movement through the interaction of two proteins. You can think of actin and myosin, which I'm sure we all know a lot about. So, they're so small and tiny, and the distance, between them is incredibly short. And because of those two factors, it requires sort of a ton of these actin myosin to really do anything worthwhile, right? And since myosin only pulls on actin a very small distance in each stroke, a large number of strokes is going to be needed to shorten a muscle by any sort of distance. And so when we think of what muscles are good for, it's like you think of like using the first gear to get up a hill in a car and a bike. They're really good for that force, that slow force, but it's not so much when we talk about speed, right? The faster the requirement of contraction, the less force the muscles can really, produce here. And the more force the tendons must have to start to produce here. So overall, don't love the definition here from Merriam-Webster for plyometrics. So we'll move on to maybe some more common terms. So, the other maybe delineation that we hear a lot is sort of fast versus slow. So the fast being if, and we're talking about ground contact times here, right? So fast being if the ground contact time is under 250 milliseconds, well, then that would be considered a plyometric. But if the ground contact time is greater than 250 milliseconds, well, then that would not be considered a plyometric. And so, the first thing you have to ask is what's the magic, what's the magic formula at 250 milliseconds, so you kind of look into, hey, what is going on at that 250 millisecond time frame to delineate something is a plyometric or something is not a plyometric. And really there's nothing magical going on at that point. It's just a hard cut, time that is utilized to maybe understand certain components of the process that may be slightly different, if something is a little bit faster and if something is a little bit slower. But again, there's nothing, nothing magical about that 250 millisecond component. So, but imagine trying to do research with that definition, right? Because you can't even do research on different forms of like running that would utilize different times of ground contact at different components of even like an acceleration up to like a max velocity sprint. So it makes it really muddy to try to define things, that way. And even in training, the applied side of using a definition like this is really muddy as well, because as a coach, I'm more concerned with clean and clear taxonomy, a clean and clear understanding of like a framework. And so, if I'm performing a training session and I may be doing different forms of the same type of activity, like a jump, which we'll get into, and some of those have higher ground contact times than 250 milliseconds, and some of those have shorter ground contact times than 250 milliseconds. And it's the strategy that I'm trying to get the athlete to utilize as we build an intensity that really determines what I'm going after. Well, then how am I going to determine which one is a plyometric and one is not a plyometric? It just makes it really, really muddy. So again, another reason why maybe that term isn't really useful, both in even a research setting or an applied setting. And then lastly, I think the history of this is really interesting. So we'll take a quick history lesson and kind of understand where that word plyometric came from in the first place and how we got here. So, the term pliometric, so plio, P-L-I-O, was introduced in like the 1930s by a couple of researchers who recognized that muscles took on sort of three different conditions when contracting. So they shorten, they maintain the same length, or they lengthen, right? So this should all sound really familiar. And what they called these three different conditions won't sound too familiar, as they term the shortening as a myometric, staying the same. That one you'll recognize, isometric. And then when something is lengthened, they discuss it as a pliometric. So as you can probably guess, myometric became synonymous with concentric, while pliometric became synonymous with eccentric. But interpretations, there was a lot of interpretations about this. It wasn't like this happened overnight, and there was a lot of people kind of trying to figure out what this all meant. So one of those people who popularized the word plyometrics was a guy named Fred Wilt. And he was a track and field coach. And he popularized the term in the US while observing a bunch of Soviet athletes who were training. And he was seeing that they would have this increase in outputs on various means or exercises following an isometric. And as he used an alternative explanation to understand what this whole plyometric word meant than those who originally defined it. So he kind of spun it and used it in a little bit of a different way. And this probably started with the translation issue, as plyometric sounds awfully similar to plyometric, but who knows? But what's interesting about this is there's a little snippet in a magazine where he wrote about plyometrics and the term plyometrics. And even he wasn't sold on it. So I'll read what he actually wrote, which again, I just think these history lessons are quite interesting. But what he wrote is the word plyometric is apparently derived from the Greek word plithrin, which means to increase, and isometric. So my present interpretation of plyometric is that it means the exercises or training drills used in producing an overload of isometric type muscle action, which invokes the stretch reflect in muscles. I am not particularly happy with the interpretation, and it may alter when a precise definition evolves, right? So that's what's interesting to me is, again, when you dive into the history of things, it's quite interesting in our field that you'll end up with some funny, you'll end up down some funny roads. And this was one that I thought was really interesting when we kind of looked into it. So ultimately, it's just confusing, right? Plyometrics means a lot of different things to a lot of different people. So what we settled on is just using a term that is used quite regularly to define some of this type of work, and that is elastic strength. It's an action, right? Strength is an action, and we already have different components of strength that we talk about all the time and everybody understands. And so that's where it just sort of using this word elastic strength as a descriptor for some of these actions really just helps to kind of put it on the same continuum as maybe some of these other qualities of strength that we discuss all the time, like maximal strength and strength speed and things like that. So the way we'll define elastic strength is the expression of high force coupling in a short amount of time. And the exercises that are going to fall under that umbrella that we'll discuss most today are going to be, oh wait, now I don't know how to do, oh, there we go. Yep. Jumps, hops, and bounds, right? So we're going to talk quite a bit about these particular types of actions. And to quickly define them, a jump, right, is taking off on 2 feet, landing on 2 feet. A hop is taking off on one leg and it's landing on the same leg. And then a bound is taking off on one leg and then it's landing on the opposite leg. So we're going to discuss those quite a bit. And really we'll get into the phases as well that the jumping leg or legs are going to go through, because that's also very common, or it's similar across all three types of actions, jumps, hops, or bounds. So when we think about what does that jumping leg go through, there's always a preparation phase. And that preparation phase is really a co-contraction of the leg muscles in anticipation for contact. So we'll get into some of that. There's an amortization phase, and upon impact, the legs are going to flex, right? You're going to bend at the hips, knees, ankles. And really what you get there is the stretching of the leg extensor muscles, the gastrocs, the hamstrings, the glutes. And then the third phase that the jumping leg will go through is going to be that extension phase, where the legs are going to extend using that concentric contraction to propel the body in flight. And it's really the specifics, the specific development of the kind of those, Jared talks about this all the time, the basal constituents within those three processes, that preparation, amortization, or extension. It's really the specifics there that we're going to get into quite a bit to really deconstruct and kind of reverse engineer as to like where we start in terms of building up those components to allow those processes to occur as we go. So we just discussed those phases of jumps, hops, and bounds. And if we were to assess any of those actions on a force plate and obtain a force time curve, we would get a graphical representation of the preparation, the preparation, amortization, and extension phases. So we would actually get to see that, and you can kind of see some force time curves right here on the slide. And this graph would give us force over time, right? And the area of that curve would be the combined force per unit time, which would be the impulse. And impulse is a beautiful thing. It's a measurable unit stemming from classical mechanics, which has much further reach within our field than just talking about jumps, hops, or bounds. So I think when we talk about like impulse, we're typically drawn towards this like speed power continuum, speed strength continuum. And impulse has a lot further reach if we kind of think about just in general what we're talking about with it. So, I like to think of impulse really as a universal performance principle, because all training, whether that's, again, speed, power, or even conditioning, like all training is going to lie on a continuum as a function of impulse, which is dependent on the interplay of force and time. So anything that we do, we're manipulating the intensity in some fashion, and we're either using forces to manipulate that intensity or time to manipulate that intensity. Really, like, that's kind of the interplay that we're dealing with. So for a practical understanding, we can contrast, Usain Bolt and Kipchoge, who are two dominant athletes in their respective realms. So obviously everybody knows that Usain Bolt's fastest man on earth, ran a 9.58 seconds, 100 meter dash, and it's ridiculous, at a average speed of like 23.35 miles an hour. So ridiculously fast. Kipchoge, on the other hand, 2 hour and 1 minute 39-second marathon, 12.9 miles per hour. For some reason, to me, running at 12.9 miles an hour for 2 hours is I don't know why, but more impressive than even what Usain Bolt did, even though they're both ridiculous. Just absolutely ridiculous. But what's interesting here is if you look at the forces and the ground reaction forces that these guys are encountering, you see a little bit of a contrast. So Usain Bolt, he took 41 steps in that race, and he's encountering somewhere in the ballpark of like 5 times his body weight ground reaction forces in a very short period of time, less than 100 milliseconds per ground contact. So what you're dealing with is a really high impulse, and a really high impulse that's dictated on high forces every time he hits the ground, and really short time, right? So he's getting a lot of force in a really short period of time. And on the flip side of that, if you look at Kipchoge took like somewhere in the ballpark of 20,000 steps. Probably someone has counted that, but it's 20,000, 21,000 steps. And he's getting about 2.5 times, maybe 3 times his body weight of ground reaction forces in less than 200 milliseconds. So the difference being, Usain Bolt is about twice the amount of force in half the amount of time. And that's how he's getting his impulse. And Kipchoge is, 2.5 times his body weight, so half of that force in double the amount of time, right? And so the principle is this: it's very, very simple. The higher the amount of force, right, the less time you're able to sustain that for. Like Usain Bolt could not just continue running at that pace for an extended period of time. He would run into some limiters, right? And so that's sort of what we see in any particular domain, whether that's, again, speed and power type components of training, or again, anything else. It all falls along this continuum, and we can really apply this to any particular space. And so that's kind of what we'll end up doing is we'll say, okay, if we double click on elastic strength and we sort of look at, well, what is the continuum of, intensity that we have available to us within this particular realm of training? Well, we're going to be manipulating things, either force or time or both. And we're going to do that in a bunch of different ways in order to, again, return an athlete or just build up the training in general. So really like this as a universal performance kind of training principle.
So that was phenomenal. I think Eric just did a really, really good job of discussing the concept of impulse and how it's critical in the demonstration of elastic strength development. And so if we look at this picture of the kangaroo and the gorilla, I kind of like to view it as a spectrum where we have this elastic strength or reactive strength, if you want to use that terminology as well. I think that's totally fine and suitable. Then we have more on the right, this max strength. In other words, we have on the left this moderate amount of force in a short amount of time. So this can be thought of as things like top end speed or sprinting, and even Olympic lifting. And then as we look on the right with this peak force or this max strength, I'm thinking through the lens of high force, but over a longer period of time. So perhaps we're looking like at acceleration or powerlifting. So you can start to kind of understand the different expressions in which impulse is derived from for these individuals in their respective domains or sports. And there are certainly situations where we may require outputs that are similar to that of the gorilla, where maybe I need more peak or maximum muscle strength or force generating capacity. But if that's all we have, or that's all we're trying to adapt within our athletes, then we might actually limit their athletic potential. And this could even potentiate injury as well, as the rate and rise of force generating capacity might actually be limited. And we understand that in sports specifically, time is going to be a constraint, right? So we have to make sure, not only from a performance perspective, but also from a moderator perspective, we need to be able to quickly have a high rise of onset of contraction to be able to decelerate or manipulate and handle our downward velocity. So, when we first look at this slide, I know it's kind of a lot. There's a lot of different things going on. We're going to kind of draw our attention towards the left, looking at the kangaroo and kind of looking downward at these terms myogenic and neurogenic, because I think these are the big components that really help out with the mechanism of demonstrating elastic strength development. So when we first look at the myogenic component, which we can think of as viscoelasticity, this is all about elastic energy recoil. So during the stretch shorten cycle or the elastic strength expression, we're going to have these viscoelastic properties of the muscle and tendon units. And so during the stretching of an activated muscle, understanding that during an elastic strength maneuver, the muscle is more so acting in this quasi-isometric fashion, and the tendon is going to be what's actually going to undergo deformation or strain. So it's changing its length as a result of external load that's applied. So understanding this, we say, well, there's going to be mechanical energy that's absorbed within these tendon structures. And this energy can then, as a consequence, be reutilized if the stretch shorten cycle happens immediately after, right? So if the shortening of this act is relatively rapid and we decrease the duration of that amortization phase, we can capitalize on the qualities that the tendon allow us to help out with demonstrating this elastic strength. And so what about this neurogenic component? Well, this is arguably even more important. And what happens here is that we're thinking about the stretch reflex. That's all the neurogenic component really is when it goes into the mechanistic action of elastic strength. So the involvement of the stretch reflex is largely based off of the message that is sent to the spinal cord from the muscle spindle. And it's highly going to be contingent on the rate of the applied stretch. So the faster the rate of the stretch, the stronger the proprioceptive signal or that afferent input. And as a result, the greater the efferent muscle contraction, meaning that there's a greater ability to rapidly switch between eccentric and concentric movement to actually maximize emergent outputs like change of direction and jump landing maneuvers, all things that are inherently elastic strength, even changes of direction. So I think the big thing to note here, as we look at this left-hand side, is that for elastic strength to contribute, there has to be a short transition period between the eccentric and concentric phases. Otherwise, its energy potentially could be lost, and we don't capitalize on that rapid rise of force production or that elasticity. And again, the reason being is because, well, when we look at the components of not only the viscoelasticity, right? But also the muscle spindle, we know that they are going to be predicated off of time, which is typically a constraint. We need a high amount of stretch, but it also needs to be relatively brief, which then would inherently allow us to deduce that, as Eric had mentioned previously, the muscle isn't going to be a huge contributor to the expression of this emergent output that is elastic strength. If we look at the right and we look at the gorilla and we think of peak or absolute force generating capacity, this is going to be more so catered towards these muscular constituents and components. So these are going to be concepts like force velocity curve or the force generating capacity, whereas velocity goes up concentrically speaking, then the output concentrically might actually be a little bit lower. And then we look at force length, which is really just thinking about cross bridging. So he also brought in to the equation actin and myosin. And we understand that at certain degrees or ranges of motion, we might have a better appreciable level of overlap that allows one to demonstrate higher peak or magnitude forces. But if we're looking at rate, well, again, this is going to be something that is happening really quickly, or elasticity, something that's happening really quickly where there's not enough time for actin and myosin proteins to adequately overlap to actually allow the muscles to be a really relevant variable in that expression of elastic strength. But this isn't to say that the muscular training these muscular qualities isn't important. So that's where we kind of come to the middle and we see we have intramuscular and intermuscular coordination, where intermuscular coordination is going to be based off of how the muscular apparatus kind of works together, how we're actually navigating, negotiating our body. So these are things like timing, synchronization, even a appreciable level of stiffness. But then we look at intramuscular coordination. This is the drive to the muscle. So we're thinking of the number of motor units recruited, the recruitment rate of motor units, or that successive depolarization rate as well. All of those will help out with increasing the muscular output. But if we combine both of these together and look through this lens, we can see that at the bottom, we can have a manifestation of a lot of different force generating capacities in respective domains. So we can have Eddie Hall here, who's deadlifting probably with his nose bleeding. I don't know if anybody's ever seen that video, but it's amazing. And this is more so looking at peak or magnitude forces. Then we look at perhaps something that is more like an Olympic lift. Then we get into acceleration, which is something that's contingent on high force or muscular outputs, but it also does have it necessitates a little bit more elastic strength because of, yes, we're constrained by time, and we have more inertia to overcome. But we're still capitalizing on the tendon qualities as well. But then when we get into our domain, basketball, that's where, hey, somebody has to rapidly go up and get a rebound, rapidly go up and dunk. This is where there's not a duration of time in which they can keep their feet in contact with the ground that would allow them to utilize as best they can muscular constituents. So now they're relying on that magnitude and rate of stretch or strain to the tendon, as well as the muscle spindle excitation that allows them to capitalize on that myogenic and neurogenic component in an elastic strength standpoint. So when we get into the kinetics and the kinematics, this is where I think things get sometimes a little bit complicated. And I think what happens is, before we even rush into implementing these elastic strength development qualities or even these tactics and the methods, we should have a better understanding of the kinetic capacities that are actually additive to the net joint outputs, right? This external mechanical power. So I think one reason that we often have a tendency to quickly implement elastic strength tactics that might actually exceed an athlete's current capability is because we have a false premise of this word functional. And so, functional, speaking of semantics with elastic, right, or plyometrics, I think the word functional has a lot of different premises as well and definitions. So, it's often going to be predicated on the extent to which a movement or movements reflect the dynamic correspondence and representative to the specific task or sport, meaning how closely it actually emulates the terminal task. So conversely, when we say, well, something that's non-functional, it's probably going to be frequently deemed as a movement which fails to demonstrate the exact kinematics of the terminal or emergent sport or task. And so I think what happens is that a lot of times people have this presumption that if we look on the left and we see Schmidt doing a leg extension, we're like, well, how does that actually allow him to eventually be able to integrate the emergence of more of these elastic strength tactics? Well, I think what happens is that these elastic or these isolated machines are seemed as futile, seemed as if they don't necessarily matter. But these isolated options can be very valuable because they allow us to really allocate stress to a specific tissue, especially if there's an avoidance strategy that offloads the tissue during the integrated or emergent reflective kind of pattern. But even thinking about, again, as we talked about, we're not going to only look through the lens of pain and injury. This could be an individual who just needs to develop more cross-sectional area if we believe that that's directly proportional to force generating capacity. And we think that that is additive in the variable of eventually demonstrating elastic strength qualities. This might be a viable option. So, what we often say is if we attempt to, have to specifically recreate these exact positions as you see on the right, we might actually lead athletes to being underprepared. Their neuromuscular system capacities aren't necessarily given the right amount of adaptation or stimulus. And so we might actually perpetuate the cycle of, yes, they are able to demonstrate this movement, but are they doing so with the necessary ingredients available? And there are going to be some potential performance inhibitors or detractors that don't allow them to do so in a manner that's effective or efficient. So with all that being said, what is our definition, our operational definition of the word function? So this is our definition, specifically mine, and it's inherently still flawed, but it's any activity that provides affordances and reduces constraints, which allow the athlete, the client, the patient to be able to perform their desired and required task. So with this perspective, we're able to appreciate how a loaded strength exercise doesn't have to create the same kinematic biomechanics as that of the terminal task, right? The manifestation of kinematics in the terminal task is, especially in basketball, it's highly reflexive, it's emergent, it's more hindbrain driven. And so what we're thinking about is, okay, well, things that are more functional from a kinematic perspective are going to be contingent on the constraints of the organism, the task, and the environment. And what constraints should we look at as being able to actually leverage and manipulate and modify at a manner that is going to influence their terminal task or have a little bit more dynamic correspondence. So if we supply the athlete with the necessary ingredients, it's important at removing or at least reducing tissue-specific force-generating capacity as being the rate limiter during elastic strength tasks. And perhaps it's more of a competency or a motor skill acquisition rate limiter in which we can then set up these task and environmental constraints for them to demonstrate what we think is a better expression of that particular activity. So kind of keeping up with this concept of kinetics and kinematics, I think one of the foundational underpinnings that really does help to guide the decision-making of exercises and parameters for the adaptation we want is this force velocity curve, right? I know people talk about surfing the curve, if you will, and understanding maybe where someone is limited within this curve. But what we're really doing is asking ourselves, does the athlete possess the basal level constituents, as we keep discussing, that are protective and set the foundation that allows them to demonstrate reactive or elastic strength capabilities. So, if you're thinking through the lens of injury, the more significant the injury, the higher likelihood the time loss is. And as a consequence, the more biomotor ingredients are going to have to be reacquired eventually. And it's really critical to understand and ensure that these necessary constituents or ingredients are reacquired to limit the residual decrement in biological as well as biomechanical qualities. Otherwise, there's going to be an inherent impediment in their ability to demonstrate the elastic outputs that you're trying to acquire. So if we were to break this curve down in a rudimentary level, it would be we go from more basal or low level to integrated and reflexive. Or keeping up with this concept of impulse, we go from high impulse that's derived from peak, and eventually high impulse derived from rate. So perhaps high impulse that is derived from duration as well, which will be more of this work capacity or structural adaptation premise that precedes maximal muscle strength bias training, specifically in a reconditioning phase, where maybe they're not in a state where they can actually generate that much force, or they're just not in a state where they can tolerate the expression of those forces either. So, I think often what occurs when it comes to kinematics and kinetics when trying to surf this curve is that the kinematics take precedent, understanding that these two variables are inherently linked together, right? There's this bidirectional relationship, but what happens is that, as we mentioned on the previous slide, we attempt to maybe too abruptly prioritize creating this dynamic correspondence of the movement without supplying enough capacity to tolerate or effectively produce forces that are necessary for the said elastic strength movements. So what we've really tried to illustrate here is that when we move from maybe the slow strength to speed strength or elastic strength, then we should be sure to provide tactics that induce higher forces and velocities of the lower limb, as opposed to only relying on max and peak force contributions that are garnered from the preceding phases within this curve. And this is really because there's substantial research that demonstrates, compensations and accommodation strategies with elastic maneuvers, as athletes don't really possess the eccentric force producing capabilities to even be able to show you elastic strength qualities. So, often we kind of fool ourselves by only, I think, assessing these final outputs, right? So whether that's going to be, I know a lot of us probably see ACL reconstructions, and maybe we'll do different hop testing. Or we look at jump height if we have access to force plates or like a My Jump mat, and we look at a counter movement jump height. But these can be unsatisfactory strategies that allow for these outputs, meaning there's different manners and solutions that are allowing them to reach that particular distance or to achieve that particular height that we don't necessarily see. But it's an indicator that they're probably missing an essential ingredient that they really need from a kinetic perspective that would help to preserve the integrity of those structures if they get into a perhaps disadvantageous kinematic solution. So, going back to this hop testing, right? The ability to produce single leg forward hop symmetry without meeting perhaps unilateral quadricep strength. Thinking through the lens right now of ACL, because I know that's something that kind of permeates our field specifically when I'm thinking of physical therapists. We want to make sure that they actually have unilateral quadriceps capacity first, right? If they can demonstrate symmetry in the hop test, but they don't meet this unilateral quadriceps threshold, this actually could be a representation of alternative strategies that preferentially incorporate the ankle or perhaps incorporate the hip complex as a solution. And so once again, we're appreciating this concept of dynamic systems theory perspective where movement solutions are going to be afforded based off of this organism, the task, and the environmental constraints. And we should realize that maybe it's more prudent to allocate concerted attention on these isolated movements and exercises to restore the quadricep strength in order to buffer any potential ramifications from these kinematically disadvantageous or challenging positions, if you will. And so I think the big thing to note here, right, and there's some articles here, is that there's a lot of different solutions for people, and it's not, using these outputs as a surrogate might not be the best representations of those particular tissues and or the qualities that you're really trying to adapt. So ensuring that from an isolated kinetic perspective, they have what they need if they have undergone an extensive time loss injury is going to be incredibly important. Or if this is someone who is a novice, or maybe they haven't been exposed to some of the more higher level elastic strength components that we'll get into, we should understand, hey, if they have a deviation that's exceeding a bandwidth, maybe it's not a motor competency or skill acquisition fault, but it's actually something under the hood that needs further investigation and remediation to make sure that that's not a roadblock to their success. So, here, okay, now we're going to kind of finally get into a little bit more of some specifics when it comes to elastic strength, okay? So we kind of delineated this, and we already kind of went over like this domain expertise at the beginning. But now we're going to even get a little bit more specific in regard to reconditioning and performance. So when we think of reconditioning and performance, and these examples at the bottom are going to pertain to elastic strength, we look at reconditioning as the acquisition of biomechanical and biodynamic capacities as opposed to performance, which might be labeled as the acquisition of biomotor and bioenergetic capacities. So now we kind of look below that, and then we parse it out even further, and we say, well, what exactly does biomechanical mean? Well, we'll define it as the restoration of movement options, right? So I kind of gave the example earlier of being able to access all the letters of the alphabet, right? Or all the relevant letters that you need in order to express yourself in the way that you want. And then we look at biodynamic, the coordination of movement options and the coordination of relevant tissues as well. So this is going to be the capacity or ability to be able to navigate, negotiate your body against gravity. So can I actually integrate those basal level joint potentials that I've acquired? So when we look all the way at the bottom, again, looking at this through the lens of elastic strength development, but it probably can kind of pertain to any other biomotor quality that you're in pursuit of. We have to descend and ascend. So descending, I'm thinking triple flexion. Do they have the joint constituents biomechanically to be able to acquire that position? And what about ascend? Well, now we're thinking of this concept of triple extension, if you will, which is a whole nother topic, but we don't have enough time to maybe get into some of the myths that revolve around that. But generally speaking, does that individual have the capacity to extend the segments or the joints in which they need to? And those are going to be things that are more towards this biomechanical spectrum. Again, restoring those joint options. Then we look at biodynamic. We have eccentric and concentric. So can they integrate those new options, and can they make sure that they have those isolated muscle coordinating capabilities and competencies in an eccentric or lowering capacity, right? Can they handle a downward velocity? And then can they make sure that they express some degree of impulse in a way that allows them to move up against gravity? And so this then allows me to ensure that they have tissue readiness to be able to receive the stimulus that Eric Schmidt is trying to provide them. And this is going to be more contingent on biomotor and bioenergetic when we're thinking more of higher impulses, right? So now they're ready to get into some things where they're actually garnering a little bit more robustness, if you will. But I just want to make sure that he's given someone, someone is brought to him that doesn't have a lot of hindrances or impediments that don't allow them to receive the stimulus that's sufficient for the expression of elastic strength. So I kind of have him discuss the right-hand side of this physical preparedness spectrum.
Yeah, so you see underneath performance where, again, talking about domain expertise, you have this biomotor, bioenergetic, and those are really the simple way I think about those is just two different ways to delineate days, right? Types of training days. Is the session working on improving the biomotor qualities, or is the session working on improving the bioenergetic qualities? And again, when I think about this too, I think about that force time curve, right? So you have the forces on one axes and you have the time on the other axes. And I think of everything sort of falling somewhere with that impulse concept in mind on that force time curve, right? So a biomotor day is simply trying to pull the top of that curve up. So I'm doing different elastic strength activities with really high forces that are really trying to pull the top of that curve up. And if I think about that curve that kind of trails off, well, an energetic day is going to really try to push that thing from the bottom and really try to push it up and to the right, you know? And so either delineation of days is just a simple way to just help me understand exactly what the emphasis is for that particular individual. And then underneath, as you can see, there's pogos, jumps, bounds, hops. These are different exercises, right? Or categories really that encompass a lot of different exercises within them that we would utilize on an elastic strength day. And then the arrows that are kind of peeling out towards the motor side or the energetic side gives a little bit of an indication as to sort of where the volume of that particular type of category would fall. So pogos being more on an energetic side, where maybe we're utilizing those particular methods to try to build the capacity of this elastic strength, versus something like hops, where we're really using those to, again, just pull the top of that curve up, and that belongs more on a motor day. So just a simple way to try to delineate what type of training stressor we're going after, and what sort of adaptation we're trying to acquire.
Okay, so reconditioning, when is elastic development actually necessary? Like when do we employ this particular quality, and then the tactics that revolve around that? So I really like this arc here. I think it does a good job of illustrating the different types of injuries that might present, and delineating into adaptation versus demonstration, and looking at the bottom in regard to the nature of insult. So the first thing that we have to do is understand the difference between an instantaneous and repetitive oriented injury. And so this is from Cal Coven. I really, really do value this definition. So an instantaneous or more acute oriented injury would be excessive stress and strain induced by application of a singular high magnitude stress, as opposed to repeated application of load at some percentage of a material's ultimate strength. And so we say, okay, well, what exactly does this adaptation versus demonstration really mean? Well, adaptation just means that there's an instantaneous injury that decreased and led to a decrement in that tissue's force generating capacity. It exceeded its stress and strain capacity and or tolerance. And so it probably resulted in an extensive time loss injury or some kind of surgery. And so this specific tissue requires a longer course to then reacquire those biomotor, bioenergetic, biomechanical constituents. Those are going to be things such as ACL tears, Achilles rupture, even a hamstring strain as well. Now, when we look at the term demonstration, perhaps these are going to be athletes who didn't have an extensive time loss oriented injury. It was something that was relatively insidious, or maybe there's just some kind of symptomology to where they have some pain, tension, tightness, some kind of unpleasant sensation that impedes their function transiently or just acutely, but not prolonged. So these can be things maybe like a back strain and or an ankle sprain, depending on the significance and the severity of that. So these individuals just need to, for me, be able to demonstrate tolerance to elastic strength tactics, as opposed to really trying to acquire an adaptation from elastic strength tactics. Then we look all the way at the bottom, we have these repetitive. These are individuals that might have some kind of ongoing patellofemoral pain, patellar tendinopathy, Achilles tendinopathy. So we look at these, they're likely variables that are, or injuries, if you will, that are a little bit more chronic in nature. They're prolonged. And so we understand that the longer something is attained, then there could be this slow degradation of certain biomotor and bioenergetic qualities. And so they do need to have a reacquisition of those. And that's where I don't want them to just demonstrate tolerance to those. I have to ensure that they actually have adapted the elastic strength qualities to make sure that we decrease the likelihood of future injury, or we make sure that we're actually improving their performance potential for the future as well. So, this arc here just allows you to kind of understand when, from a reconditioning lens, elastic strength is actually a little bit more necessary. And then it also can potentially tell you, after you kind of see this next slide that Eric will go through, of maybe what types of methods are a little bit more effective to implement when we have someone, let's say, that's on this repetitive end that has patellofemoral pain versus patellar tendinopathy. They might be limited from a pain perspective on the options that allow them to demonstrate elastic strength. Someone with patellofemoral pain, perhaps they're going to more shallow or limiting their depth as opposed to going incredibly low, because maybe they're getting more patellofemoral joint stress as opposed to patellar tendinopathy. Maybe I am okay with them sinking a little bit lower as opposed to stopping shallow, because if I stop really shallow and have them rapidly jump back up, what am I thinking back to? That neurogenic myogenic component where I'm utilizing the tendon. And so that might actually be a little bit more provocative, as opposed to allowing them to sink a little bit lower, maybe even the normal, increase their duration. And now we understand if I increase duration, the muscular constituents actually are additive in the output of elastic strength. And so I'm lessening the demand on the tendon.
Yeah, so we'll talk about this, like when is elastic development necessary? And so what I wanted to do here was at least paint a little bit of maybe a big picture view of how we might think about some of the important factors involved in sort of this long-term view of elastic strength development. So, again, classic Strength Coach 101, we're going to break down any given training year into these three phases. You have a general preparation phase, and the general preparation phase is really going to be the off season, right? The majority of the early off season, bleeding into maybe the mid to late off season. And then we have a specific preparation phase, which again, late off season, bleeding into preseason, and maybe in the beginning of the early stages of a competitive season. And then obviously we have the competition phase, which is the season, right, all the way through the entire duration. So if we think about just big picture view, we have those three kind of phases of time. We might be able to apply some general framework around the volumes and the intensities and the frequencies of these particular activities. So in a general preparation phase, we're really dealing with low to moderate volume of elastic strength, low to moderate intensity, and we're really dealing with like 2 to 3 times. Frequency is generally around 2 to 3 times a week. Again, these are very ballpark scenarios. Your training situation will dictate a lot of this, but ultimately that's generally speaking what we end up seeing here. And then in the specific preparation phase, we might now get into the moderate to high volumes, moderate to high intensities, and your frequency might drop 1 to 3 times per week. And so again, we'll see the volume decrease a little bit, the frequency decrease a little bit, but the intensity begins to go up there. And in the competition phase, low volume, high intensity, there's generally no time here to implement like low intensity type work. It really is maybe even maladaptive at that point. And the frequency is, I put 0 to 1 times per week, because it really depends on what environment you're in. I've been in environments where I will use that weekly stimulus of some really high intensity elastic strength development. And then there's environments kind of like what I'm in right now, where that's basically all they do, right? So, and there's so much volume and there's so much intensity in that I would maybe take some things from a training standpoint and apply those elsewhere, right? My resources are going to go elsewhere at that point. So those are some general ideas how the framework builds there. And then when we look at like the taxonomy, the way that the taxonomy works is kind of underneath that. So you sort of have 3 buckets where the methods will go. And so you have these in place elastic strength work, you have a dynamic, and then you have these shock methods here. So the in place is really has 2 variables. There's conditioning variables, and then there's vertical ground reaction force domains, really, right? So generally I like to categorize based upon the ground reaction forces, but this one's a little bit unique in that at times during a general prep phase, you may actually need to acquire a lot of volume and really build some specific conditioning towards these particular methods that really benefits, later on in the phases. But if we are trying to do like high volumes of low intensity or moderate intensity elastic strength work, it generally only lives in that GPP phase. It doesn't really live in an SPP or a competition block, right? And so that's where you see that little arrow that took me way too long to figure out how to do the colors with. Jared's really good with the slides, but you have the green arrow right there where, again, that's associated with the GPP phase right there. So conditioning methods live there, and then you have your vertical ground reaction force methods there. And within that are specific kind of keystone exercises that I would utilize in those particular areas there. So you'll see, it's not an exhaustive list, but you'll see certain exercises followed there. So underneath conditioning, you have multi-jumps, you got pogos, and you have light-weighted jumps. And again, those are things you would do for long durations that are relatively low in intensity. And then vertical, you'd have counter movement jumps, counter movement hops, and light-weighted jumps as well. So there might be certain types of vertical ground reaction force jumps you would do there. And then as we shift over towards the middle, you see the dynamic categories. Now we're moving through space, right? And now you see the two categories underneath are vertical domains, and then you have horizontal. So vertical ground reaction force and horizontal ground reaction force. And so vertical consists of like hurdle jumps, hurdle hops, and heavy weighted jumps. And horizontal is short bounds, short jumps, and short hops, right? So one of the things that we talk about a lot too is and I've heard people in their categorization will use like hurdle jumps being, well, hey, you're moving forward. Isn't that a horizontal force, vector that's occurring to have somebody jump over a hurdle? But realistically, if you actually watch people when they do these hurdle jumps, they're actually encountering quite a bit of ground reaction force in the vertical plane there, even though there is a horizontal component to it. So it's really trying to delineate that way, because that helps. Again, it just helps with an application from an application standpoint. And again, not an exhaustive list. There is a lot of different versions that we do in here, but these are sort of some of the keystone. And then moving over to the shock methods, you got drop dump jumps and you got depth jumps. Realistically, that's pretty exhaustive of a list. There's very few other ways to kind of get at that particular aspect of training intensity. I always think of the Boo Schexnayder quote. He said, you could be fancy or you can be intense. And when it comes to this particular work, stop being fancy, focus on the intensity. And that's sort of how I think about the application of this particular work. It's really looking at understanding the spectrum of impulse and how we can manipulate things. But ultimately, I'm trying to drive these things this direction, because the intensity is really where a lot of these adaptations are going to be acquired. So that's sort of a general big picture framework.
I won't spend too much time on this slide, because I think we've already done a good job of just thinking through the lens of, again, injury manifestations. But I think what actually happens when we think about injury and their associated ramifications, we can see this for one, this very simple schematic that really does display how max strength or max effort, rate of force, and then eventually reactive strength or elastic strength might actually impede someone's progress or ensue injury. It's an ingredient in the manifestation of injury, but not the only ingredient, because that's, again, this complex phenomenon as well. But if we look specifically at max strength, right, the inability to produce maximum muscle force, this lowers the ceiling for force generating capacity. But we don't want to only try to reacquire that. We probably do want some, which sometimes is a relatively ambiguous or nebulous term, rate of force, that permeates our domains as well. But if we have injury, we actually might lower the ability to apply high force in a short amount of time, right? The rate and rise at which force is actually going to be produced is going to be dampened. And this is important because when we think about things like ACL rupture, especially non-contact, this occurs in less than maybe 50 milliseconds, while the quads require around 300 milliseconds sometimes to actually reach peak torque. So we're starting to understand, like, these things, the injury, but not only looking through injury, but the physical preparedness shouldn't only rely on tactics that help out with the adaptation of max effort or max strength qualities, nor should it rely on tactics that help out with trying to improve rate of force, but we also need this elastic or reactive strength as well. Again, we want to make sure that we have enough mechanical stiffness from the tendons themselves, but then also just making sure that this person becomes more competent and has capacity to handle the intensities and the volumes, specifically in our domain. When we think about 82 games and maybe they play 3, sometimes 4 games a week, they might have back-to-backs. Can we ensure that we're preparing those tendons and the tissues that are additive to the expression of elastic strength? Can we make sure that they have the ability to repetitively store and release energy, or have this recoil over and over and over again? So that's the main premise behind this slide, is just understanding that we don't get stuck on the first 2 qualities, but we really do a good job of trying to understand the best means and methods for trying to help out with reestablishing elastic strength. So constraint-led testing. We talked about constraint-led lens, right? Which is looking at that person, functional, structural, as well as task and environment. Now what we're going to do is say, well, what about the testing domains or assessment domains? Here, I think what's important to understand is that what we're trying to do is have this audit system. We're trying to, when we think about like plan, do, check, and act, we're trying to have this process that allows us to be held to some kind of accountability in regard to whether or not what we have implemented from an intervention perspective is actually manifesting in the way in which we really do want and is actually meaningful to the athlete. So these are some different categories. There's probably other categories that are relevant as well. But for the sake of this particular concept, we kind of delineated it into as 4 different categories that I think hopefully allow you to see how it fits back into the frameworks that we both have of biomechanical, biodynamic, biomotor, bioenergetic. So we have this movement or joint restoration, right? Relevant ranges of motion. And this might be more relevant for individuals, again, who are coming from some type of an injury where we can take, for example, someone who, let's say they have an ankle sprain and or some type of ankle arthroscopy, that we could say, all right, well, we need to improve their joints range of motion or dorsiflexion range before they are integrated back into something that's as dynamic, reflexive, and high intensity as a elastic strength tactic, especially something like a shock method, right? So we're understanding like, hey, they're going to inherently be constrained. There's going to be a rate limiter before they even get to that particular phase or quality that they need from a training perspective. Moving on, we have mechanical isolation, right? So this essentially is just looking at the isolation of a particular tissue and its ability to generate force production. That can be done in a concentric or an eccentric manner, or even an isometric manner as well. But there probably should be some kind of inference into whether or not that tissue is up to par with its contralateral limb or some kind of norms that you have available. So, you know, from here we can look at specifically something perhaps like a calf strain, or some type of Achilles rupture or Achilles tendinopathy, right? Where we're thinking about, hey, yes, we want this individual to have some appreciable level of flight time or jump height, but they might be precluded from that because they can't even perform 30 single leg hill raises. They don't have isolated calf capacity. So trying to reacquire that is going to be prudent before they get into some of these more emergent tasks. Looking at then mechanical integration. Now we're starting to think about more of the mechanical or external mechanical power or elastic strength. So we can look at things potentially like transit hops, understanding that these aren't necessarily the best proxies or surrogates for the relevant tissues, because there's different accommodation strategies, as we alluded to earlier. But we can look at just these stationary jump landing iterations as well. We're looking at hops and we're looking at jumps, and we're getting different metrics from the force plate. And then lastly, emergent locomotion. As we talked about, elastic strength does help out with the ability for someone to express higher capacities and competencies with changes of direction, just based off of the fact that there is going to be a reliance on the tendon, again, thinking of not only that neurogenic, but the myogenic components, the magnitude and the rate of stretch on the muscle spindle, and then the ability of that tendon to store mechanical energy and then release that. So hopefully this allows you to then reverse engineer to say, hey, this individual is exceeding some bandwidth or is outside of the norms within the cohort that we have. Well, how do we ensure that the constraint is actually a motor or movement skill acquisition, or is there something under the hood that is a roadblock? Well, let's kind of reverse engineer and go up this tier to see, is it a mechanical integration type of fault? Okay, well, if that isn't at an appreciable manner, now let's look at mechanical isolation. So it allows you to start to understand your starting point. And like we talked about, this hierarchy of need, what should I actually prioritize? Having some kind of system like this that looks at constraints will allow you to discern where you should start. So, you know, with that being said, now what we're going to do to kind of close up everything is discuss a case study. And so as I talked about earlier, this is where myself and Eric really want you all to have dialogue back and forth with us. And maybe Scott can help out here with trying to get people to chime in. I don't know if you want to have people ask questions on the chat box, or even just ask people, have people chime in vocally as well. But what we're going to do is we're going to go through this, and the big thing is understanding, like we just went through, this reverse engineering process, right? Looking at the different types of tests or assessments that would give you more of an indication as to where you should start or what potentially is the rate limiter. So what I'll do is I'll read this athlete complaint, and it says, during the off-season GPP or general physical preparation phase, your athlete reports focal inferior pole patella pain, specifically when performing jump landing maneuvers when participating in pickup games, right? So we can think of that as they probably have some kind of patellar tendinopathy. During training, there are noticeable movement deviations or load aversion during bilateral lifts. What does the reverse engineering process look like to determine rate limiters and progress towards elastic output, capacity, and tolerance? So again, think back to this particular slide and everything we've discussed to start to determine, okay, I'm looking through this lens of constraints. What am I deducing? What am I implementing to lead me down the route of this is likely a patellar tendinopathy issue, but even more importantly, maybe what are some of the intervening points in which I can actually try to resolve and rectify this issue?
And so what I'll have you do is, if it's a quick thing, put it in chat. If you want to jump on, just go down to the bottom right-hand corner where it says reactions, click raise your hand, and then I'll grab you in. That way we don't get too many cross things going on.
Great. And maybe
I can't see anything too, so I hope somebody's asking me.
I don't think.
And if we don't, it's totally fine. You know, we can go. We can roll through this, right? Because we're kind of closing up anyway.
We're getting some stuff. So Shelby says torque production. Ben Lee says, can you specify what you meant by noticeable movement deviations?
Yeah, so someone who, let's say they're performing any kind of integrated task. So a goblet squat, a back squat, a hack squat, and you notice that when they go down, let's say that this is on their left side, right? Their symptomology is on the left. You notice that they're shifting, they have torso shift towards the right. They subjectively tell you they feel like they're loading and pushing out with the right lower extremity. That's kind of what I mean by aversion to load on that left side that is currently symptomatic.
Gotcha. So her feedback then is knee extension, limb symmetry index, or strength to body weight ratio. Right. And Alex is saying, is it load specific, i.e. does body weight look different than load, or load placement specific, as in back versus hack versus front squat?
That's a great one. Yeah, that's great. Which is all, I think, relevant information to try to discern. So, you know, what we would say, right? Our first thing that we would potentially look at is, well, what is the mechanical integration, right? And this is something that we have the privilege of being able to actually employ and utilize to make some inferences, which are force plates. So mechanical integration, again, we're thinking of things potentially pertaining to this that might give us a better surrogate or proxy into that tissue's readiness and symptomology. Things like eccentric deceleration, impulse asymmetry, right? That might give us an idea of that person's tolerance level to loading if we see eccentrically, so the lowering portion where they're about to reverse their downward acceleration and impulse, as we already discussed, there's an asymmetry there where perhaps they're offloading the left side, and that asymmetry is outside of their previous norms that have been established. So that's already probably starting to prompt us to maybe investigate further. We could look at maybe a metric called eccentric duration. Sometimes this one is more so in the research alluding to fatigue, but we could also look at it from a perspective of maybe some type of lower limb tissue injury as well. Why is that the case for patellar tendon? Well, eccentric duration is, as we talked about, if I'm using my tendon, the eccentric duration probably isn't going to be that prolonged, right? I want to get off the ground as quick as I can. If I'm symptomatic within the tendon, then perhaps the eccentric duration is lengthening because I'm not relying on the tendon properties. I don't want to be as rapid with my reflex. And so I'm going to maybe use my muscular constituents a little bit more than tendon. So maybe eccentric duration does go up. So that might be another proxy. And then lastly, concentric impulse at 100 milliseconds. This is something where we're just looking at their ability to, again, rapidly get out of the amortization phase. So it's the first 100 milliseconds where they're pushing up. And so this is something that might, again, give you a indication of whether or not they're load averse, or just prompt you to investigate further that symptomatic side. One reason why we didn't put on jump height here is because it might not be the best proxy to assess tendon capacity, because again, they can demonstrate alternative solutions and still reach the same jump height, especially if eccentric duration is longer, where they're just staying in contact with the ground longer to still generate force. So it's just a different solution. So jump height might not be the best indicator for this individual. I don't know if you want to add anything there.
Yeah, solid. Yeah.
So
we're rolling.
So then,
so Jared, I wanted to clarify here. When you're saying eccentric duration, you're talking about this is force play assessment of counter movement jump.
Yeah.
And as you know, most of the people don't have that. Do you have a solution for that using something like My Jump or other options that would let them get something similar?
Great question. Yeah, I haven't used My Jump. I know some people that have, and they've found it to be quite beneficial and have some utility. If you have, then I think you certainly can speak on that, Scott, if you think that it does have some utility and allows people to gain some inference into duration. But I haven't myself actually used that. I don't know if you for
no, not definitely not in this context. So yeah, but also go ahead.
I was just going to say it does work, but not with the counter movement jump. You would have to do the depth jump, because then you're going to get ground contact time compared to flight time, which is really what you're discussing here. Counter movement jump on a force plate lets you see that, but because the phone will not identify onset of movement for a counter movement jump, you need a distinct starting point, and that's where it does have the ability to do that. So there are some, fortunately, some great options. I think that just because you don't have force plates doesn't mean you can't look into some of this stuff.
Yeah,
absolutely.
And I think even just looking at, it's maybe underrated to just film things and slow them down yourself. I think if you know where a particular person is experiencing, pain or having issues, to put them in, in tasks that are going to require them to use those tissues, film them, look at their strategies and kind of assess that. There's a lot of stuff I think you can generally pick up that you might not catch the first time in real time, but if you're watching how they're strategizing to perform that task while using those problematic areas, there's a lot of stuff you can pick up. So I tend to film a ton of stuff. I know we tend to film a ton of stuff, and really just try to assess that as well as another layer.
So keeping up with this, again, reverse engineering, mechanical integration, now mechanical isolation. So I think people did a great job here already. Torque production, right? Concentric and eccentric torque production. Concentric, absolutely, but I think eccentric might be beneficial as well for this individual, specifically if they're having challenges with the downward control of velocity. But then we can also look at a single leg decline squat. I think this is totally fine, right? If we don't have anything that allows us to have some type of an insight into torque production, if you don't have an isokinetic dynamometry, if you don't have any kind of like a handheld dynamometry, then maybe you perform something like this, and it's a better proxy than not having anything, at perhaps looking at someone's tolerance, where you can even measure this as well, where you have them on a decline. You take out some type of a measuring device, right? And then you have a valve slide and they go out as far as they can. And now you can gain an insight into side to side, how far they were willing to excurse, but then also subjectively, what was their pain scale 0 to 10. So that's the mechanical isolation piece. And then lastly, we can continue to deduce and say, well, what if the single leg decline squat was limited and painful? Well, let's potentially look at closed chain dorsiflexion. this isn't something that is on the top of the list. It's probably not something that I think warrants a lot of investigation. But I do think that, again, it could be a potential variable that perhaps doesn't allow them to sink down to be able to utilize quad to maybe protect the knee or be additive in the expression somewhat of elastic strength development. So I put additional triple flexion constituents here, or any other areas that might be an impediment for that person to be able to demonstrate some degree of loading and excursioning through a range of motion that might prompt them to have overstress or overload or exceeding that tendon's capacity. So this is just a way to look at and reverse engineer the elastic strength development process, specifically when we're talking about someone with patellar tendinopathy. So again, closing things off, because I know we're probably a little bit over here, Scott, but I briefly do want to go through this. So patellar tendinopathy, what does a general, again, aerial viewpoint of this look like as we kind of surf this continuum? We might start with potentially the first two are going to live somewhat in this reconditioning domain expertise, where, again, I'm trying to provide Eric Schmidt an athlete that's ready to be sufficiently and viably loaded from a biomotor, bioenergetic standpoint. So I want to improve their load tolerance. These are going to be things that maybe are more constrained, 60 degrees, progressive leg extension, isometrics. Again, isometrics aren't the holy grail. There's a lot of other types of options. These are just simple exercises and examples that we put here. So by no means don't take this as being gospel. As we kind of continue to traverse this, we go to load capacity. So now we're thinking about being able to do, maximum muscle strength oriented exercises. We're getting into some integrated isotonics and definitely some eccentrics. If this person, again, has challenges with going into triple flexion based off of our reverse engineered constraints assessments. So maybe heavy slow resistance is suitable for this individual, especially, for us, if they're in season and they're battling some type of patellar tendinopathy, and we don't want to load this individual every single day, but we want some type of adaptations if we believe mechanical stiffness is actually a thing that we're acquiring, or single leg loading, right? Eccentric work. I do want to briefly mention here, eccentrics, I think, are really important. And sometimes one thing we didn't really touch on is that elastic strength development. A lot of times people will use elastic strength or, quote unquote, plyometrics as a means to say they are adapting or building eccentric strength. But again, understanding that the muscle is quasi-isometric. So a lot of times it doesn't go through a large strain or a large range or excursion of motion to actually receive a true eccentric oriented stimulus. And then the other thing that I want to point out is, a lot of times when we're trying to implement eccentric strength training in order to then graduate towards true elastic strength, because I do think that's important. Sometimes we get into this realm of a lot of time under tension eccentrics, where now the external load is going to have to inherently be decreased because I'm prolonging the duration of the eccentric. And so I don't give them an appreciable level of external mechanical stress and strain through that tissue. And so it's just important to understand, again, those tactics and methods, not to say that time under tension isn't important and a viable option eccentrically for perhaps motor control and coordination, but maybe not so much for these non-contractile musculotendinous unit structures. So with that being said, right, so we go load tolerance, load capacity, this intramuscular coordination component, and then extra criteria that might be more prudent for me to ensure that they're ready for the stimulus is maybe we go back to that single leg decline squat test. Do they have tolerance with that? Quadriceps torque, can they demonstrate not only tolerance with that, but do they have the capacity? I know this is a lot in ACL literature, but I think it's relatively important too, especially in our domain, for individuals to be able to have 100% body weight. And then obviously from there, maybe we would look at limb symmetry index, but I think we just first want to pull things up to make sure they're at a solid level, and that's not the rate limiter. And then they would go to load rate and elasticity with E. Schmidt, where all along they're still going to be in his domain, right? We don't want to, if this is out of the season, right? Back to the case study, GPP, they're still going to be working with him. They're not siloed and walled off only to me. Because they have to still maintain fitness qualities, right? We're not only going to be looking at the patellar tendon. So there's always going to be, again, this symbiotic relationship and this communication. And so certain things that we might look at here as extra criteria are drop jump pre-injury or pain values, as well as maybe we're looking at less than 10% eccentric deceleration asymmetry, or whatever they were prior to the onset of symptomology. And then lastly, last one, Scott, I promise.
You're good.
So here we look at elastic strength development continuum, right? A few kind of specific examples pertaining to this case. You know, at the top, you see we have extensive. So these are things that can be done for a prolonged period of time, or maybe there's a higher volume with these because the intensity is inherently low. These are preparatory oriented elastic strength activities that I would ensure that they can demonstrate tolerance with, so that, again, going back to the same narrative, I know that they're ready to receive a higher, more rigorous and demanding stimulus from Eric. We would get into deceleration, right? Eccentric tolerance. These are things like drop squats, fake med ball slams, short landings where they, you know, start tall and snap down. People call them snap downs. People sometimes call them, you know, low altitude landings where they're stepping from maybe an 8-inch box and landing down. But I'm just trying to improve confidence, increase tolerance as well. And there's some examples of volumes on the far right with sets and contacts and days per week. You can notice that those are relatively high because, again, the ground reaction force in which they're going to encounter isn't incredibly high. And then we get into number 2, acceleration, right? Propulsive tolerance with this, which typically isn't an issue, but sometimes it definitely could be. So I think it warrants its own like delineation before we start to couple things together. So examples of these are box jumps, non-counter movement jumps here, and then grounded med ball throws. I like non-counter movement jumps because, again, we're almost eliminating to a certain degree the strain and stress on the tendon. Its attributions to the expression of elastic strength might be dampened somewhat by doing a non-counter movement jump. And then we slowly start to add back in a little bit more of the challenging variables. And so, you know, after 1 and 2, they would then be more so permitted to performing 3 and 4. So I don't know if Eric wants to briefly touch on those.
Yeah, I'll take those. So yeah, I mean, we're looking at the force coupling, energy storage, and release. So now you're actually getting into what I would consider to be maybe more the higher end elastic strength exercises, things that you would typically perform in a strength and conditioning setting. And all the while, I'm just assured that this individual has the requisite capacity to be able to handle this type of work. And then it's like, once they get inserted into the process, it's, hey, where do they fall on this continuum? And so here's some examples of, again, multi-jumps, hurdle hops that they may be performing. And it's up to me to determine, you know, hey, what is the volume of work that we should be doing for this individual? You know, how many contacts in a given session? What's the intensity, which can be for something like a hurdle jump, obviously dictated by the height or by the distance,
already started,
things like that. So there's just different ways to manipulate that. And those are conversations that are had in relation to some of the above categories in terms of what has been achieved with this person before they come into this training environment. And then I'm just, again, dosing things as appropriately as possible to try to build these adaptations. And then obviously building up towards some of these more advanced, again, shock methods, which are a little more rare to get to in this environment, but certainly can be achieved by some individuals. So it's really this back and forth. And I'm just always looking for that assurance is, hey, what is this individual prepared to do? And I think the constraints-based approach really does support the ability to dig under the hood and find out what they are actually capable of being able to handle, especially in my domain. You know, I think it's really a popular saying is like, don't build strength on top of dysfunction. And a lot of times we're thinking from a movement sense, but I think it's just as pertinent to think about, don't try to build function on top of faulty ability, right? Faulty strength. And so, you know, from elastic strength, there's a lot that goes into this. And to be able to handle the appropriate volume and intensity and frequency of this work to acquire any sort of like adaptation, it really does require a good understanding as to where this person is and what they're currently capable of handling. And I think that just becomes a really important component of our communication to be able to determine that.
So I'm going to stop share. And that is kind of the conclusion of our presentation, right? I know that was quite a bit. And again, it's more so this aerial view, right? We didn't get into the nitty gritty, all the different nuances, but we just wanted to provide some of these mini frameworks in which now maybe we help people and we prompt people to ask better questions or investigate the literature a little bit more, to be able to discern, how to actually implement some of these things, or maybe what are some of the pitfalls in regard to their tactics and strategies.
Well, awesome. Thank you guys so much. I know we're over, so everybody, but we do have some questions.
Oh,
Do
sure.
you both have time to answer?
Yeah,
I want to be respectful.
we got what, five? Want to go to five
Yeah,
minutes? Yeah,
let's
we got about 5 minutes. It's 6:55 here, so
All right.
we've been up all day, man.
My
But no,
bedtime,
we
like,
got
I
it
don't
though.
know.
Hey, I mean, we were supposed to be done 25 minutes ago, so good on you guys going this long.
Yeah, we like to talk for sure.
Yeah. So quickly, Shelby had a question about whether increasing peak strength is always positively going to improve reactive strength, or if there's a ceiling we may hit while increasing strength, it no longer makes an appreciable difference in reactive strength. I did refer her to the talk that the point counterpoint Quinn and I did, so to sort of lay some of that out. If you have anything beyond what you stated there that you wanted to, feel free.
Yeah, I'll hit that one. I mean, in general, there's carryover to a certain point probably, but again, these particular activities are constrained by rate, right? And so it's not just the absolute ability to express these like force producing, these force qualities. Because as soon as you introduce that time component and you don't allow somebody the enough time to generate high levels of force, then you see people crumble pretty quickly, in trying to do maybe some more of these like advanced jumps, hops, bounds. And so I'm a great demonstration of that, where like I'm just I'm probably okay in the generating a lot of force and like power lift type exercises, but you try to get me to do some of these more emergent jumping, hopping, bounding type skills, not as athletic looking for sure. So I think that's just the main component. Is for a lot of the individuals we work with, we do see a big carryover there because they are so skilled at that piece of things, and maybe the quality of just building strength in general really does have an immediate transfer towards the things that they're already good at, but not the other way around so much. So that would be my just basic answer there. But great question.
And Scott, like we talked about, is this opportunity cost, right? Like what am I giving up by going down this long route of trying to acquire peak force or absolute strength, right? It takes a lot of time, takes a lot of resources and energy away. And then it doesn't allow me to fill the cup of elastic strength. So there's always going to be, again, that opportunity cost or something that I'm leaving on the table if I try to endeavor down that route.
Yeah, and to put it in terms that Eric can relate to, that's time you're taking away from filling out your t-shirt a little bit tighter, right?
Exactly. Yeah, exactly. Which is unnecessary time. Really.
Exactly. That's important. Two more brief ones.
Cool.
This one might be a little bit long. So John did ask how you determine whether you use more bioenergetic or biomotor techniques. Is it based off of a periodization model? Is it something that's individualized? You did kind of cover that in your talk, but if you want to briefly touch on that, you can. I think it's fine if you just say, we don't have time to get into it.
Yeah. Yeah. I mean, maybe a lot. It's certainly, you're going to take the individual into consideration for sure. And there's, you saw some of the assessments that maybe will put people through, but there's certainly a lot of those. I think in general, a beginner can benefit quite a bit from more skewing towards the energetic side and just building capacity. And you'll start to see the higher levels of abilities sort of rise in a general sense. But it's definitely a blend of both. I think that's sort of why things are delineated that way. It's like, depending on the individual you work with in basketball, it's obviously a high level of outputs needing to be sustained for long periods of time. So it has to be a blend of both qualities. It's the general strength and conditioning concept, right? It's just like you have to really have both, but wherever that individual falls on that continuum is certainly dependent on who they are, what their age is, what their training experiences is, and some of the evaluations that we'll put them through. So I would say, yeah, from there it's split.
I mean, it really comes down to, you need to do a needs analysis. So it's hard to answer that question without knowing who's being worked with. So you guys work within basketball and you have a very diverse set just within that. But then when you're in a clinic, like if you don't know the needs, it's not. So I think the models and the frameworks that you laid out answer that question if you go back with the understanding that you have to do a needs analysis. Very briefly, because I thought it was a good question, Shelby asked how sprinting fits into your elastic strength continuum. Is there a certain degree of participation in elastic strength training you want to have your guys go through before returning to sprinting? And you got 1 minute.
So I'll say really quick, I'll let Eric specifically touch on the sprinting, but there probably are kind of like we just talked about with that patellar tendinopathy case, right? That elastic strength development continuum. There's going to be some prerequisites, or at least some level of going through and traversing through a continuum where they've been exposed to high forces, and then we talk about, well, first slow forces, then higher forces with more velocity, specifically of the hamstring complex. We want to make sure that they do so in a constrained manner, then it becomes less constrained, then it becomes more emergent, so we feel that they're in a position ready to receive that high rate of force production and that high strain rate on the hamstring. So there might be, within the periodization process, and I'll let Eric speak more on this, but there's going to be some key staple movements and tactics that we're implementing before we simply go right to sprint application that I think allows them to be able to handle and tolerate that a little bit more. And I do want to make sure, because I think you did a good job of just trying to elucidate that ground reaction forces that are vertical, right? Because I think a lot of times people think that, oh, well, if sprinting, like you talked about, if something is moving in a horizontal fashion, then we only do horizontal based vector-based activities, right? But it's like, well, they still have to overcome gravity. So there's still going to be a vertical ground reaction force there. And so they still have to get a cyclical movement where the other limb goes forward. There still has to be a vertical ground reaction force. So all I'm saying there is that these vertically directed counter movement jumps and bounds or hops that are in this direction are also really, really valuable options and preparatory in nature before they get to sprinting.
Mm-hmm. Yeah, I mean, it's a great point. And I know we just talked about mostly jumps, hops, bounds as kind of part of this elastic strength component, but certainly sprinting falls along that similar continuum as well, you know, but I think it's tough because you got to assess the environment you're in. So like in our environment, for instance, guys aren't reaching top speeds. The court is small. The guys are large. And so they're more in the acceleration phase of kind of that continuum there, which if you look at some of the adaptations that would occur in doing like acceleration based training versus doing some of the more elastic strength stuff that we're talking about, there's definitely some crossover there. And there might be some nuances to training specifically with like sprinting. But I think you get a lot of bang for your buck in our environment from some of this jump, hop, bound work that you see a lot of that carryover. Cause again, just, yeah, we get into like the ground reaction force components and their ability to traverse like into improving changes of direction and improving deceleration and things like that. So I think there's a lot of that, but certainly your environment matters quite a bit for sure in that question.
Awesome. Thank you so much. I appreciate your time and everybody who stuck through to the end. This will be recorded and available.
Yeah,
thanks a lot
for sticking around for that whole time.
Yeah, I appreciate it.
No, it's good. I mean, it's your time, right? You guys are the ones that get to decide. So thanks so much for the time. Jared, good to see you again. Eric, we need to do a little better than occasionally talking on Instagram.
I agree.
And
I agree.
yeah, maybe I'll make a trip up that way.